The rule like say.
Just put a finger.
Ask it to really make it deliberate like this, because you just can't be straight.
And then you have to put a finger.
Never be straight.
Okay. So we introduced there are two ways to learn the acids and the bases. The first one is the arenes. It's called arenes acid is the substance that produce proton, and the base is produce the OH. And the second way is like the donor or the acceptor. Okay, here to show some strong acids and weak acids. Strong acids means they can completely dissociate, but these weak acids, they cannot 100% dissociated. Okay, question. Identify each of the following chemicals as a Bronsted acid, base, or both.
Acid C, base B, A both. Is that smart?
E base.
Bronsted acid means is proton donor, right? So which can release proton. So A is acid or base? Acid. B,
Base.
yeah. B is base because it can accept. And the C, both. Why? C, what C?
Yes, yes.
It's a base.
It's a base.
Is it a base?
It's a both.
Yes, yes. So both right.
Because it can release proton, right? It can donate, it also can accept proton. So C is both.
So smart.
So A, it can release proton.
What's that? What's that?
What?
HL. What's L?
Hi, item. Item, yes. And B can accept proton. Okay, so it's base. And the C can release or accept proton. Okay, so it's both. Okay. So this is the second one. Second one is about the acid base. Second one is about this acid base reaction. So this kind of reaction is called neutralization reaction. When acid reacts with base, it will give the solid
And water.
and water. For example, for this is the acid, this is the base. So the hydrogen and oxygen will form the water before the. So this is also called a neutralization reaction. Neutralization reaction means the products are not acids or bases. Okay. So, and they form the water. It gives the water. So for this reaction, this means strong acid and strong acids and strong bases. so they form water. But sometimes the acid may be weak acid. For example, weak acid can react with strong base, and it also forms solid and water. Okay. So in this case, the difference is the weak acid should be written like this because it's weak. Okay. If it is strong acid, strong base, the net anionic reaction will be like this. Okay. But for the weak acid, the net ionic equation should be like this. So the weak is a molecule. It's a molecule. And then to form, yeah?
What acid is that?
What acid?
Yeah, what's the name of the acid?
This is acid, HCN.
No, what's the name?
I just know I don't know how to say you using in English. Yeah, but the structure like this. How to you see this?
No.
This one?
No, it is.
Where?
No.
Yeah.
Not that one.
That doesn't show.
So the structure is like this.
Stop. Being shot.
You see it, right? Okay.
Yeah.
Okay. Yeah, the structure of this acid is like this. This is acid, okay, and this is carbon, nitrogen, and the between the carbon and nitrogen is triple bond. I only know it's Chinese name. It's in Chinese name is 氰酸. 氰酸, yeah. But in English I don't know. Okay. Okay.
Cyanic. You have Google it? Yes. Acha. Cyanic acid.
So sometimes the acid and the react with base, it can give gas. For example, this reaction, okay, the sodium peroxide is, for example, reaction after the reaction, it's released this carbon dioxide, okay, the gas. So the net anionic equation should be right like this. You should keep the gas molecule here. Okay. So from here we can see when we use different acids and bases, they are net anionic equations may be different. So for the strong acids and bases, it's very simple, like this. Okay, but it's a weak acid, like this. And also, if it's weak base, you also write here is the proton, and here is the weak base. Okay, and for this acid-base reaction, it releases gas. The gas will release from the solution. It is structured like this. Its equation will include the gas. Okay, so this is the second one. It's about acid-base reaction. So the third one is oxidation reduction reactions. So this means in these reactions, the electron transfer between the substances. So it's also called electron transfer reactions. For example, this metal can react with oxygen like it's born in air. So it's form this product. So in this reaction, we can see at first the metal is zero charge, right? The charge of zero is zero. And then it loses 2 electrons. And the oxygen get each oxygen atom gets 2 electrons. So from here we can see after the reaction, there are 4 electrons are transferred from the metal to oxygen. So this reaction are called the oxidation reduction reaction. And for other reactions, for acid-base reactions and precipitation reactions, there are no electrons transferred between the substance. But in this reaction, the electrons are transferred between the atoms. So for this one, it loses electron. It's called oxidation half reaction. For oxygen, it gets electron. And is called reduction half reaction. Of course, this half and add this half, this is the whole reaction. This whole reaction is called oxidation reduction reaction. So anyone, any question for this? So from here we can see, we can write the reaction like this. So this half, okay, add this half. So 2 metal, oxygen, and 4 electron. And so the right sides, this one here and this one. So the electron. So finally we get this. So in this reaction, you need to figure out how to write the oxidation half reaction and the reduction half reaction, and add them together. You can get the whole reaction, whole equation. So the process like this. This is to show the process of this kind of reaction. This reaction is happened between 2 different metals, metal ions. For example, the zinc, we put the zinc bar into the cup solution. Finally, we can find the cup will cover the surface of the zinc bar. So this means at first like this. This is zinc bar. So this is zinc atoms, and the zinc in cup solution. The cup is the zinc at first. Zinc bar of course is 0. The charge of zinc bar is 0. It's a metal, right? And when it is put in the cup solution. So the electron will transform from zinc to cup. So the cup will get 2 electrons and form the cup atom. The cup atom is metal. Okay, so you can see the surface of the zinc bar. You can find the cup metal. Okay. So this is another example. It means this is cup bar, but it is put in the silk solution. So the electron will be transformed from copper to silver. So the copper becomes copper iron. It goes into the solution, and the silver cation come from it covered the surface of the copper from the solution. So here this is copper bar, and finally, because of the surface of copper bar, we can find the silver. So in these two reactions, we can see the electrons are transported between the substance. So this kind of reactions is called oxidation reduction reactions. Okay. So, for example, these two reactions can be like this. So first, zinc solid react with copper solution, and they form release the copper solid. Okay, and the zinc get 2 electrons, and is the reducing agent, and the copper is reduced, so it's called oxidizing agent. Oxidation. Okay, so basically we're just have the class for you. I speak English. This is the only time, or sometimes play soccer. I play. So okay. So question. So the copper wire reacts with silver nitrate to form silver metal. So what's the oxidation agent in the reaction? Okay. Oxidation. Basically, so this is right. So after 1 year, I will have this course for next year's students. So maybe after 1 year, I forget it again. In my age, it's difficult to learn language. When you are a young child, it's very easy. It's very to learn language. My daughter, and she at first she come. I stayed American for a couple years, and my daughter also went to stay with me, right? But before went American, she doesn't know any English. He's just 8 years old. 8 years old. In China, 8 years old, just almost nothing. This is more than 10 years ago. Now in China, if you are 8 years, you can still learn English, okay, in elementary school. But 10 years ago, my daughter know nothing, don't know A, B, C, no. So at the first half year, and he it's difficult. Definitely, it's very difficult for her, right? Because I don't know any English. And I remember, and also she told me, her teacher just asked 1 or 2 students to help her, but only after half year she can talk. She can talk with everyone.
English is easy.
Yeah, of course, English is much easier than Chinese.
Chinese.
Chinese problem, I know. So people, some people, they know many languages, like English, French, right? Because they are very similar, right?
Yeah.
But Chinese is totally different from other languages.
Opposite.
Yeah, yeah. So I know it's very. So for children, it's easy for children to learn because just half year. But for example, if I stay here for a couple years, definitely more than half year, right? But I just improve. Of course, I improve my English, but not so fast as my daughter. This is why.
So
I
how
think,
old is your daughter?
oh, more than 20. Yeah. Yeah, she's working. She's working in America.
Okay.
Yeah. She stays in America now. Yeah. My daughter got his undergraduate degree in UT Austin. So I stayed in UT Austin. Texas, University of Texas at Austin. It's a very nice university. It's a big university. It's a public university. And then she got his master degree in Michigan University. It's not nice. So he found a job in New York. I think many Chinese have this kind of experiments. Yeah, I worked here for a couple of years, and then I bring my daughter to here, and she can learn English, and then she can easy for her to go to a university, and then something like this. Okay. Question. So in this reaction, which is the oxidizing agent?
The one in aqua solution, silver.
Which one?
Yeah, silver.
Silver.
Copper.
So why? So oxidizing agent should get electron. So which one get electron?
It's copper.
Copper get yes. No. Copper get. So
Copper.
it should get electron. So which one get electron? Copper or silver?
Copper.
Copper.
Silver. What?
For this in this reaction, the copper 0 changes to post charge, right? And the silver is +1. So finally it becomes 0.
It lost. It gave away.
So which one gets electron?
Copper.
Silver.
Come on.
It gave away. Oh wait, plus one.
So
It was positive.
silver.
Then became neutral.
Silver get electron and then change from +1 to 0, right? So silver is oxidizing agent. Okay?
Oh wait.
So copper lose electron. The silver get electron. Okay? So silver is
Silver there is an ion.
the
On the
oxidizing agent. Okay. So any question for this? Okay, oxidation number. So each atom has oxidation number. Maybe you can say, oh, it's neutral. Hey, it's neutral, its oxidation number is 0. Okay, so it may be positive charge, has positive charge, maybe negative charge. Okay. For example, if the free elements, of course, they have oscillation number of 0. Okay, and for metals, for most of metals, basic metals, they have positive charges. And for like oxygen, in the oxygen, usually it's -2, but sometimes it can be -1. For example, in this area, O2, 2 minus. So each oxygen is -1 charge, -1 charge. So all these charges are oxidation numbers. So and also we know, for example, the sodium, but hydrogen basically hydrogen has the +1 charge, but sometimes it may have the -1 charge. For example, when it's combined with the sodium, the sodium is easy to lose electron. So in this compound, the sodium is +1, but the hydrogen is -1 charge, minus charge. And when the group 1A metals are +1 charge and the 2A are +2. We introduced this before, right? When we introduced the And of course, some of the oxidation numbers of all atoms in a molecule or ion is equal to the charge on the molecule or ion. It should be the compound. Basically, the compound should be neutral. If a neutral compound, and the minus charges should be equal to the plus charges. And the oxidation numbers don't have to be integers. Okay, they may be like this is -12. Okay. Now question. What are the oxidation numbers of all the elements in this guy? So when we determine the oxidation numbers of all of the elements, we basically firstly think out the common ones. For example, in this case, we know basically hydrogen basically is +1 charge, right? It just show -1 charge with sodium. And oxygen, basically is -2 charge. So after we think out the charges of the common atoms, so we can think out the atomic carbon. Because carbon it can show more oxidation numbers. So anyone want to what is the charge? What charge of the carbon? So in this guy, the hydrogen is +1 charge. So oxygen is -2 charge. And what the oxidation number of carbon? Nobody want to try? What are you doing?
This one.
Yeah. You said Maurice.
Maurice.
Oh, Maurice, yeah, Maurice.
Oh, yes. Morning.
Oxidation number of carbon.
Wake up. Morning, wake up.
No, more doesn't sleep today.
He's a busy boy. Today's the ladies, ladies. It's the ladies. Blessing. My English is representing.
Blessing representing Zimbabwe.
Okay, nobody want to try? Okay, just give the answer. So hydrogen, oxygen -2, right?
Good.
Hydrogen +1.
Carbon.
And 6, so it's like 3 oxygen and 1 hydrogen. And finally, the whole molecule is should be minus 1 charge. Okay? So from here, we can say, what is the charge of the carbon? So here, for example, here is minus 6, right? So at the 1 is minus 5. If we move to here, it's 5 minus 1, right? So it's plus 2, yes. The charge of carbon is plus 2. Okay, so basically, when you do calculations, you need to be careful. The whole molecular is minus 1 charge. So it should be, here is not 0, okay? It should be minus 1. Minus 1. Okay. So this table to show the common charges of these elements. For example, basically in this there's plus 1 charge, plus 2. Okay, and for this fluorine is basically always minus 1. But for others, the paper show many different charges, Okay. Okay, now question: what are the oxidation numbers of all the elements in each of these compounds? So here we can say all these compounds are neutral, right? Yeah. So for example, in this guy, sodium, iodine, and what's it? Iodine. Okay, iodine. You know, in another way, I should thank you. You know why? Because if not this course, I have no any chance to speak English. So after a couple of years, you know, my English will be. Okay. So for example, in this case, sodium plus 1 basically. So oxygen minus 1. So we can figure out the charge of this guy, right?
How do you find the pain?
Okay, anyone want to try?
What is that? You.
Stop pointing at people, go at the points.
We need 3 students.
Sorry about that.
3.
But then that,
So basically, my you know in the Chinese, when I have a Chinese classes, if I have question, so basically I start one by one, and also start from the last one, last step. Yeah.
Yeah, but you could.
Yeah. So 1, 2, 3.
good.
And now next question, monitor. What's the fourth one? Fifth one. Who is back? 6. You 6. 7, 8, 9, 10, 11. Okay? Yes, you are first one.
And then when I finish, I put like on man.
Wait, check just for them one.
Yeah, no one. I would see from my chair.
Yeah, that's all.
First time before that's all very
Wait, how do you bring
we have a caraba. Good. Welcome 1, 2.
Running.
Good. So just
Yes. Because it's neutral, so it should be 0.
so 8 is equal to 5. 6.
I'm putting then 12.
8 is equal to 6.
Good. No, minus. Oh, no, sorry. Plus. Yeah, correct. Right? Yes, it's correct. Okay, second one. Hurry up. No. Oh, okay. He finished one. Okay, you.
So it's the first time.
Yeah, it's.
Yeah, so next time we're going to Francis.
Look at the one. Okay.
What's that?
If 7.
Always minus 1. Yes.
It's negative one.
I keep paying attention. There's already someone in front.
That one, where are you going? That one, where are you going?
I remove beast mode. Why?
Let's get this.
Why? I remove beast mode. George remove.
Attendant.
What?
Attendant.
what you're doing.
Hey, yo,
No.
Margot, sit.
Come down. It's still entering, it's still here.
Wait there, wait till the eraser. I look
Relax.
You have to multitask.
at please, man.
You can't write when you put the eraser.
Yes.
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 Can you write
Yes. Yes. Okay. Good. So one.
Smart, so smart.
You can run.
But that one is hard.
It's not.
No, you just pick the one by one, you know.
It's panicking.
Just write on top there. Don't erase.
There's no space exit. Funny.
No.
I'm very tall.
Really?
Connecting.
Very important. Okay, here. Okay, oxygen is
Come on, man, clear the pen.
funny.
I remove beast mode.
Oxygen. There is one.
Oxygen, minus 2, yes.
Right. Then, one, right?
Plus 1, yes. It's 1A group.
Yeah.
Yeah.
Then we don't know. That's the one who activated the pen.
So then, then it oxygen. Then, so 2 times 1,
One each
right?
other.
Times 1. Then, 2 there's a 1.
Why is that? What are you doing?
Huh?
Oh, that's module. Okay, never mind. It's module. It's a modification.
X. Yes.
Which one is it?
Then,
No, but you're 7.
It's neutral.
It's not 7x, it's 710.
yeah, we
No,
don't know.
they won't play my time.
Yes. So minus 15 and minus
So
14.
that one is plus 2x.
6.
That one is it plus 2 times 12.
I think it's 9.
Then write properly.
Tingisha.
Yes.
I thought you meant
Yes, correct. Because here, you know, the minus 14, right? 14, and then the 2, so minus 12. And the move here is 12. Minus 12 and 12, and the 12 divided by 2, 6. Okay? Yeah, good.
Clickens.
So smart.
Okay. Yeah, so the process like this. So basically, the first one, we bring out the sodium, oxygen, and then we will on this guy, right? And then in this case, we know chlorine is -1, okay? And in this case, oxygen we know is basically always -2, and this guy +1. Finally, we get this.
So, yeah, I'm confused. So, the essence of doing this, what I'm doing, this thing is like iodine. So, what I'm trying to say is, they differ, they vary. I mean, if we know sodium is +1, how about iodine? Do you know that it's
ID basically you can like +1 from +1 to, you can see here.
The first one, the first. Hey, one more.
Yeah, see, this guy. So it can be -1, +1, +5. So it can show different charges. So you need to think out which charges. But for fluorine, it's always -1. Okay, and this guy always basically always +1. And oxygen is really basically is most of CH situation is -2. So this is why we can think out this easy ones firstly, and then we think out others. Okay. Okay, that's all for today.
With one question, let us submit the code.